Hello, my dear student. Today, inshallah, with a new chemistry lesson about observing chemical changes. Firstly, inshallah, in this lesson, we study the two types of changes. We have chemical changes and also we have physical changes. What is the difference between both of them? So, firstly, we have to define what is meant by matter. Matter is everything that has mass and occupy or takes up space. Anything around us, yes, anything around us like solid, liquid, gas, all of them are matter. Solid, liquid, gas are a state of matters. We have solid matter like book, like tablet, like mobile. We have also liquid substances or liquid matter like water, like juice, and so on. Gases matter like all gases around us, like nitrogen, oxygen, helium, and so on. So matter is anything or everything around us that has mass and occupy or take up space. So we have this solid, liquid, and gas. The solid substance in which the particles are held together or packed together or tightly together. There is no spaces between them. There is no motion of them. Only they can make vibration. But liquid substance, they can move more freely than solid, but less than gases. The spaces between them is medium. Uh, and the last one is gases, in which we have the fastest particles that can move fastly, and also we have more spaces between them. This one is solid matter, like bricks called rocks. We have liquid matter, like this one also. We have gaseous matter, like a gas cylinder, fire extinguisher, and also balloons. All of them is gaseous matters. So what is the properties of matter? Matter is often described by its characteristics or properties and how it changes from phase to other phase. So the properties of matter, there are two kinds of properties of matter. One of them related to the structure of matter, related to the internal structure of the matter that we cannot see it. It's called the chemical properties. And the other one is something obvious, something external, something we can see it, something we can feel it by our five senses called the physical properties. So we have chemical properties and the physical properties. Let's start now with physical properties. If you want to describe the external shape of the penny in figure, for this one, for example, it can be described as solid, shiny, and also hard. So this one is physical properties. The physical properties is related to a kind of changes. Take the same name called the physical changes, like crushing a can, like melting an ice cube, like boiling water, like mixing sand with water, like breaking glass, like dissolving sugar in water. Just only we changes the state of matter. This one is called the physical changes. So the physical properties can be changes by physical change. So the external of physical, the example of physical changes like this one, for example. So the physical property is the property of substance that can be observed. We can see it. We can observe it without changing the substance into other substance. Like this one, like the melting of ice, like for example, like folding paper. All of them is physical properties. So physical properties, you can describe it. You can watch it easily by five senses like temperature, like length, like mass, like volume. All of them is physical property. So the temperature at which a solid substance melts is a physical property, boiling point, melting point, and so on. So color, texture, density, and conductivity are other physical properties of matter. The texture may be smooth, may be rough, and so on. The density may be more dense, may be less dense. The color may be any color like black, white, any one of them. Conductivity also, it may be good conductor or bad conductor of heat or electricity and so on. So density is a physical property. Density is related to or referred to the mass distributed over a volume. For example, if we compare between oil and water, oil has density less than that of water, so it can float over the surface of water. While if we have metal, for example, like iron, it can't sink in water because it has density more than that of water. So the substance with more density, it can fall down. The substance with less density can rises up. The conductivity is a physical property. We have some substances can conduct electricity, like iron, like metals. Uh, Also, we have other types of substances like wood, like paper, all of them that cannot conduct electricity, so they are bad conductor of electricity. The other kind of property is called the chemical properties. So the chemical property is the characteristics of a substance that describe its ability to change into other substances. So chemical properties related to the chemical reaction, related to how can we change the substance from phase to other phase, from form to other form, from substance to other new substance. So once we produce new substance, this one is chemical properties. Chemical properties like oxidation, like chemical bonding, like coordination number, like heat of combustion, like toxicity, like flammability, like corrosivity, like also reactivity. Also, we have other example of chemical properties like acidity, like reactivity. Some substances can be reactive, some other substance cannot be uh, react easily, so it is classified as inreactive substance or inert substance. So the chemical properties like all of this one, toxicity, oxidation state, heat of combustion, chemical stability, and also flammability, enthalpy of formation, possible chemical bond, reactivity, coordination number, all of them classified as chemical properties. So the chemical property, to observe and describe the chemical property, you must try to change it into another substance. So this one is a must. You have to change the substance into another substance. Like this one, for example. Shown a penny that has turned into green. This color change demonstrates a chemical property of penny's cover coating. This one is related to tarnishing, related to oxidation also. So the chemical property like this one, the rotten of apple, this one is related to chemical property because it changed it into new substance, change it into new form that we cannot use it. Example. So how it takes place? When copper is exposed to air, it reacts over time to form a dull, crusty solid. This one related to oxidation. So what is oxidation? Oxidation is meaning that the metal combine with oxygen gas to change the oxidation number of the substance, to tarnishing it, to make it something dull and crusty solid. This one is a chemical property. Another chemical property is a material's ability to burn in the presence of oxygen. This property is called flammability. Some substances can be flammable, another one is cannot be inflammable. The flammable one can burn easily. The inflammable one cannot burn easily. So this one related to flammability, as we know. So changes of matter. Like properties of matter, we have two properties of matter, chemical properties and physical properties. Also, we have two changes of matter. One of them is called the physical change related to the physical properties and the chemical change related to chemical properties. So what is physical properties or physical changes? Physical change is any change that alters the form of or appearance of a substance but does not change it into another substance. It only changes the external shape of the substance. It can only change the state of the substance. It can only change the temperature of the substance. It can only change the texture of the substance. But there is no new substance is formed. So physical changes like breaking glass, like mixing candies, like shading paper, like folding paper, like melting ice, like chopping wood, like cutting hair, like dry ice, sublimation, like boiling, like melting, like freezing, like condensation, all physical changes, all physical state changes related to physical change also. So the physical change something we can observe, it's something we can see it. So physical change, when you cut an apple in half, you can cause a physical change. Physical change because this one is the apple. It does not change, it does not alter it to another substance. It does not form new substance. There is no routine, there is nothing happen, only the volume change, only the shape changes. The physical change, in a physical change, the sum of the physical property of material may be altered, but the chemical composition remains the same, stay the same. like bending, like crushing, and cutting are all examples of changes. Changes in the state of matter, such as melting, freezing, boiling, are also physical changes because it just only changes the state of matter, just only changes the physical state of matter, only the shape, only the external appearance of the substance changes. So cutting also is a physical change. Bending is a physical change. Also, crushing crushing is a physical change like this one, but the chemical change is related to the structure now. So sometimes when matter changes, its a chemical composition is changed. For example, when a cut apple is left on the air or out in the air, it turns brown. This one related to chemical changes, which is related to rotting and so on. So rotting is a chemical change. This one, for example, because the apple change into new substance, this one is chemical change. Rotting is a chemical compound in the apple react with oxygen in the air to form new compound. Once we form a new one, this one is chemical change. Yes, so a change of matter that produces one or more new substances that can alter, that can change, that can vary or make a change in the chemical structure of the substance, in the internal structure of the substance. This one is chemical changes. So chemical changes like iron rusting, like burning wood, like metabolism, like also cooking an egg, like baking a cake, like electroplating, like also rotting a banana, like vinegar and baking soda mixture, like fireworks, like chemical battery. All of them are chemical changes related to the structure. So the chemical changes the atom rearrange to form a new substance. So a chemical change is accompanied with a physical change. But physical change is not accompanied by chemical change. So the chemical change is accompanied with physical changes like this one. Here is the reaction between hydrogen and oxygen to produce water. We observe that the bond is broken down in the reactant and rebonded, reformed again in the product, which changes a kind of bonding between them. So in a reaction, atoms are rearranged. Rearranged meaning we make new substance, make new rearrangement. So the chemical reaction is defined as the breaking of the bond in the reaction. The something before the arrow is called reactant, and the something after the arrow is called the product. We make rearrangement in the reactant to produce new one in the product, like the factory. In the factory, you put something inside it called the input to result or to produce new one, which is called the product. So this is a reaction. In the reaction, we make chemical change. So chemical change is accompanied with physical change, but not vice versa. Physical change is not accompanied by chemical change. So when a substance undergoes a chemical change, it results in different physical properties as well. For example, this one, the color change. But the change of the color is not desirable. We don't need it. We don't make it. But when you bend or you color the paper, this one is physical change because you intended to make it. So when a substance undergo a chemical change, it results in different physical properties as well. So the chemical change is accompanied by physical or with a physical change. Example of chemical change like burning and rusting are both chemical changes because we produce new substance. In this picture, we produce ash, and ash can be returned back to the wood. So this one is chemical change. So one of the properties of the chemical change, it is irreversible, meaning it cannot return it back to its initial state. And in the second picture, we have iron, and this iron is rust. Rusting is related to or caused by the reaction between the metal and the oxygen gas in the air, and this one accompanied by a change in the oxidation number, change the oxidation state of this element to result in new substance. So chemical change is simply a chemical reaction. The new substance that form our product. So the substance that react with each other, this one and this one, is classified as reactant. But the one which is produced is called the product. So we have reactant, we have product. So the new substance is called the product. So the substance before the change, before the chemical change is called the reactant. But the substance which resulted from the chemical change is called the product. So this is a chemical reaction in which react hydrogen with oxygen to produce water. Hydrogen is H2, oxygen is O2 to produce water, which is H2O. Here is we have to balance the chemical reaction. Balance the chemical reaction to apply the law of conservation of mass. For example, how many oxygen here? 1. How many oxygen here? 2. So we have to put here 2. But the number of hydrogen here is changed. It turns into 4. So we have to put here also 2. During the balance of the chemical equation, we have to change only the coefficient. Only the coefficient, not the structure of the element. So in this one, we have bond between hydrogen and hydrogen, and the bond between oxygen and oxygen. But in the resulted one, we have a new bond between oxygen and the hydrogen. So this one is chemical change or chemical reaction. So the chemical change is simply can be defined as a chemical reaction. So the chemical reaction, it looks like a factory in which we put something inside it called the input to result or to produce new substance called the outputs. So this one is the introduction to the chemical change and the physical change. So bonding are chemical changes. Chemical changes occur when existing bond in the reactant break down. We have to break down the bond in the reactant to form new bond in the product. For example, this is hydrogen reacts with oxygen to form new bond between oxygen and hydrogen. So the something before the arrow, or the substance before the arrow, is called reactant. But the one after the arrow is called product or called resultant. So what happened to the bond here? This is a chemical bond that attaches the atom to each other, and this one also is the bond. We have to break the bond in the reactant to form a new bond in the product. So chemical changes occur when existing bond in reactant break and new or breaks and new bond form. As a result, a new substance are formed or produced. So this is the chemical reaction. We have to break the bond in the reactant to make new bond in the product. So this is bonding. So atoms form bonds when they share or transfer electron. The reaction picture in the figure involved the breaking of shared bond and the transfer of electron. For example, here is we break down the bond between oxygen and oxygen to form this structure. Each oxygen, according to Lewis dot diagram, is surrounded by 6 electrons because it exists in group 6A in the periodic table. This one also surrounded by 6. And here is the reaction between metal and non-metal. As we know, we have metal that lose electron or donate electron to the other atom, which is non-metal. But the non-metal, which is oxygen, gain the electron. Here is we have lose and gain. The metal, which is magnesium, loses electron, but the non-metal, which is oxygen, it gains the electron to make a chemical compound called magnesium oxide. So the breaking of shared bond and the transfer of electrons, this one is related to the chemical change. How it takes place? Oxygen gas in the air consists of molecule made up of 2 atoms. Once it consists of 2 atoms, it's classified as diatomic. For example, we have 2 kinds. Sodium, for example, consists of 1 atom. This one is what? Monoatomic. Also, carbon is monoatomic. But nitrogen is diatomic. Hydrogen is diatomic. Oxygen is diatomic because it consists of 2 atoms. So this one related to the structure. So this bond break when oxygen reacts with magnesium and the new ionic bond forms. Why ionic bond? Because we have oxygen that gains electrons, so become an ion, negatively charged ion, and the magnesium loses electrons, so it turns into cation or positively charged ion. So the four ionic compound called magnesium oxide. Magnesium oxide, which is white powder. So this is the reaction between magnesium and oxygen to make magnesium oxide, which is a white powder. So the result of compound magnesium oxide, a white powder, has properties that differ from those either on magnesium or invisible shiny magnesium or invisible oxygen gas. This one is shiny magnesium. For example, while magnesium melts at 650 degrees Celsius, magnesium oxide at 2800 degrees Celsius. So this means that the properties of the resulted compound is totally different from that of the elements that make it, the reactants that form it, for example.